Thank you, Femi. So, as Femi introduced me, this is my project, this is what I've been working on, and I will be giving you an introduction and some background. In UK in 2020, there were about 33 million cars in operation. Therefore, finding parking has become one of the most repetitive urban problems. And on top of this, UK is on track to become net zero by 2030, resulting in an increase of electric vehicles charging stations that will have to be placed strategically across the city. Therefore, understanding the behaviors and patterns of parking will be crucial, for the councils. The research question was, how could the council better optimize or improve their pay and display parking with the use of computer vision and predictive analysis, resulting in the aims of creating an artifact and making further suggestions, as well as enhancing other types of parking, the electric vehicles, and the disabled base spaces. Methodology and methods. So I've downloaded the video footage of a car park. I have 3 categories of data sets. They include the pay and display ticket machine logs, the EV charging transactions, weather reports, and holidays data, just to name a few. The artifact has been subject to usability testing and user experience questionnaire. I have followed the literature review methodology. I have got ethical clearance. I have used DSDM as a project management approach. And I have used computer vision, more specifically image processing with predictive analysis and data analysis. The results show that the weather and time and day influence the parking, but no significant correlation was found for the school holidays. Comparing multiple parking locations could lead to further implementations that could be applied by the council. Also, discrepancies between the valid ticket counts from the pay machine ticket log also against the video have been seen, but this has caveats around it. And also with the disabled base spaces, you can see when they are utilized and for how long, or has caveats around it as well. In terms of the EV, the plug-in time has been higher than the charging time. Also, there were preferred charging points, and also patterns for popularity and non-popularity days and times were seen. For the usability testing and questionnaire, all tasks have been completed, and they give a good average per scale. As you can see in the figure, the artifact scored above average to excellent compared to benchmark. Moving on, the artifact strengths were the life count, the vacancy predictions, the map view, and the individual location page. I have used LSTM and multiple vacancy for predicting multiple vacancy prediction intervals, and give an overall good evaluation. In terms of the image processing testing, I have obtained 86 to 100% accuracy, but this depends on the location used and the parking type used. So in conclusion, this tool will serve the local authorities, and it could be used for further implementations, such as revenue improvements, policies, funding, reducing the CO2 emissions, helping with the parking search issue, and even security. The citizens' view on the artifact has been positive from the usability testing, and the results support existing research and could also help existing research and possibly challenge existing research, but this has some caveats around it. As any other project, it has limitations. The acceptance of the system could not be tested by the councils, as I haven't heard back from them. The generalizability of the results due to the data sets used, and the camera position, which needs to be a top-down view. So before I show you the artifact demo, I just want to present to you that the artifact is for 2 user types, the council staff and the citizens. So the citizen will be a possible improvement, and the council staff will split into general and system expert. So I'll be presenting you the general council staff. Just one moment, please. Thank you. Okay, so this will be the page they land on, and they will have the user types. They will see where the instructions are and the dataset sources. They will select the council staff. Then, for example, location RR with 24 hours quick summary. So in here, they can see the date range, they can see the weather details, they can see the live count from the video, and they can also see how the live count from the video compares with the valid ticket machine log. So you can see the discrepancies. You can also see the disabled base spaces, you can see the count, as well as the tickets sold for each tariff time bracket and the amount collected. You can go to the menu and change the date for a different date, and the data will represent that date. Moving on, you can see an in-depth analysis for location RR. So in here, I'm looking at the whole data set, and I can see the total counts per tariff time bracket, which machine has been used for what type of ticket that has been sold through it. And I can also see the discrepancies between the video count and the valid tickets count. This will be the disabled base spaces video count. I'm comparing it with the weather data. So, for example, the mean temperature, the wind average, the rain, and I can also see the rainfall classification, and I can see the daily average for that type. Same with the wind. I have a heat map for the weather, and the user can change the date so they can have a more in-depth view. And in here, I'm comparing my pay and display ticket machine logs with the holidays data from different perspectives. Thank you. The user can select a different location, for example, location A, and they will see the quick summary for location A, or they can look at all locations for pay and display. So they will. And in this page, I'm comparing the location RR with location A from different perspectives, as you can see through the graphs. Now they can look at all locations for electric vehicles, so I can see which charging points have been more used than others. I can see the difference between the total time, total count per hour for the EVs, and also the total count per day for the EVs. And I can extract patterns of popularity and non-popularity. Okay, so now I'll be presenting you what the system expert console staff will see. So, why is it? Okay, so they will choose the system expert, and they can see the information architecture of the artifact. They could see the files and flows used, and then here I'm explaining what has been done, how are the files named, and what data cleansing, where is those files, and they can also see the LSTM models, for example, the results, what prediction has been resulted from that, how are the files names, and all of those details. Okay, moving on, I can see you now what the citizens will see, and this is what the citizens will have access to. So as a citizen, I can choose location RR. I can see the address. I can even get Google Maps directions to that address. I can see the live count, and I can see the vacancy predictions. And this will be for both regular and disabled base spaces. And I'm also informed that this location does not have an electric vehicle charging station. I can see the tariffs and how much you have to pay, when the charge is applied, the capacity for this location, and the popular days based on the daily average occupancy percentage for both regular and disabled base spaces. Now I can go, as a user, I can go to location A, and location A will also tell very small text that location RR has more available spaces, so it's close by, you could go there if you want to. And everything on the map, so all locations on the map is basically shows you the live count, the prediction count, and the fact that does it have a electric vehicles charging station or not. And this is everything on the map. So just lastly, as any other artifact, I have artifact instructions. So in here, I'm explaining the user types. I'm explaining what can be accessed under each user type. And I'm also explaining that the graphs, most of the graphs are interactive, and I'm explaining how you can use this interactiveness. And that is it. Thank you very much.
You guys cannot be proud of yourself more than anything. So, questions for Denise.
Yeah.
Could you comment about the 100% accuracy?
So, yes. It depends on what space type has been used. So for 100%, it was a disabled base space, and it was very little movement. So that's why it resulted in a high accuracy, because there was almost no movement, and all the movement that happened was very, like, it picked up as a correct accuracy.
As a follow-up to that, essentially you're describing that there was very little data that was changing. So would that mean that that was essentially overfitted?
For the image processing, yeah, no, there wasn't. So I'm using image processing. I have took the video, I took the frames, I have converted them in gray scale. I have applied binary image, and I counted the non-zero pixels, and I determined how many non-zero pixels do they have to be in order to decide that that parking space is occupied or unoccupied. So I do have caveats around it, because on some of the cases you could see people crossing, and that will be picked up as, yeah, it's occupied, but they are just the people crossing. Or there is another scenario where somebody left a trolley inside the parking space, so that is picked up as it's occupied. So that resulted in 86%.
I think so one more question following up with that. What he wanted to know is, because there are limited data, particularly for the disabled ones, was there an opportunity to have done maybe an overfit check? So things like cross-validation or something like that, to be sure that there isn't overfit, because there's limited data, and that might result in that 100% that you might have done in that.
Yeah, that will be part of the further work. This is just V1, and there's a proof of concept of what it can be done.
One more question? No? Yeah?
So I like the presentation. Just want to understand about the sort of customer or citizen side of you. From my understanding, it's basically, so the person wants to know, I presume, how many spaces are in the car park or such.
Yep.
Yeah. Does that take into account of, from the moment they sort of like look to see how many spaces are, to the time they actually arrive to see if there's like the interchangeable of spaces being available or not?
That's why I have the life count, which is right now, and then I have the predictions. So I have multiple predictions intervals, and they can, let me just stop it. As you can see in 10 minutes, this is how much is predicted. In 30 minutes, this is how much is predicted. These predictions are based on the ticket machine logs details. So it's a high difference, because the video is a video, and it says there are only 55, but the actual machine logs say something else, which is the true data set.
Data, say like, for example, like a Saturday in town is very busy, so from data that I'll predict that certain times will be busier from that moment going forward.
So, yeah, on Saturdays, yes. You could use this, or you could, if today is Monday and you want to know how it's going to be on Saturday, you could see like a percentage of how occupied it is.
Okay, yeah, let's give it to the